Hello everyone, I am Anubha Gupta, Assistant Professor in the Department of Applied Science and Engineering. Today I am going to discuss the derivation of single slit diffraction. So the content of today video is the expression for intensity due to single slit diffraction. So this is the experimental arrangement for single slit diffraction. This is the monochromatic source S, which is placed at the focus of the lens L, at the focus of the convex lens L. And we know that when the light passing through the convex lens, it will be become parallel and it will incident on the slit of width E. E is the transparent portion of the slit. AB is the slit. A and B are the corner of the slit. So the parallel light, which is coming from the convex lens, it will be diffracted at angle theta. It will be diffracted at angle theta. Now this light will again incident on the lens, convex lens L2, and this light will be converged at the point P, and the point P, we will place the screen at the focus of the lens L2, and the P is the point P where the intensity, we will calculate the intensity of the light at the point P. The point P is maybe maxima, maybe minima, or maybe secondary maxima. It will depend on the path difference between the two rays, which is coming from the point A and point B. So further, we will find out the path difference between the two rays. This is the ray 1, which is diffracted from the point A, and this is the ray 2, which is diffracted from the point the B. So what is the path difference? For the path difference, we will draw the perpendicular. We will draw the perpendicular from the point A to the point from the point A to the ray second. So BD is the path difference between the ray 1 and ray 2. The path difference is BD. So this angle is theta, this angle is 90 degree, and this angle is 90 minus theta, means this angle BAD will be theta degree. So what is the value of BD? Value of BD is E sine theta, because sine theta is the perpendicular upon hypotenuse. So this is the path difference BD. Now we will find the phase difference. Phase difference between the two rays which is emerging from the point A and the second ray which is emerging from the point B. The phase difference between the two rays is 2 pi by lambda into path difference, and the path difference is 2 pi by lambda E sine theta. This is the phase difference between the two rays 1 and 2. But now we will know, we know that according to Huygens principle, the light is coming in the form of wavefront, and each and every point on the wavefront is behaving as the secondary source. So there is the n secondary source. There is a n secondary source between the point A and B. So we will find the phase difference between the two consecutive secondary source. So capital phi is the phase difference between the first and last point. But the small delta, this is the phase difference between the two consecutive point. And total point source are small n between the point A and B. So 2 pi by lambda E sine theta upon n. So what is the n delta by 2? From the here I can calculate the n delta by 2. N delta by 2 is equal to pi by lambda E sine theta. This is n delta by 2. Now by the n polygon problem, we know that how to solve the vectors which have the same amplitude of A, side A, and all are deviated by the angle phi. If we will calculate the resultant magnitude at the point P by the vector calculation, we know that capital R is equal to A sine n delta by 2 divided by sine delta by 2. So we will use this phenomena in our single slit diffraction. We will use this tool only for the single slit diffraction, that what is the intensity at the point P. And we know that there is the n secondary source, and each secondary source is have a phase difference of small delta between the two consecutive point source. So let us calculate capital R. Capital R is the amplitude at the point P. So capital R is equal to A sine. Let us suppose n delta by 2 is equal to alpha. So here n delta by 2, we will put n delta by 2 as a alpha and delta by 2 as a alpha by n. So n is very large number. So I can write sine alpha by n is very nearby to the 0, and we know sine 0 is the 0. So it can be written as sine alpha upon alpha by n. And this is the NA sine alpha upon alpha. So capital R is equal to NA sine alpha upon alpha. A is the amplitude of the small secondary sources, and there is a total n secondary sources. So total amplitude is capital A sine alpha upon alpha. Capital R is equal to A sine alpha upon alpha. This is our main expression from we can decide about the intensity at the point P. So what is the capital R? Capital R is equal to A, capital A sine alpha upon alpha, where alpha is the n delta by 2, and we already suppose the n delta by 2 as a pi by lambda E sine theta. So let us discuss the three cases for the point P. Point P may be principal maxima, point P may be minima, point P may be secondary maxima. So we will discuss first principal maxima. Principal maxima. Capital R is equal to A sine alpha upon alpha. For the principal maxima, we know that the R should be equal to A. For principal maxima, it should be the case that all the the sum of the magnitude should be equal to the total amplitude R. So R is equal to A by alpha. We will open the expression for the sine alpha series expansion. The series expansion for the sine alpha is alpha minus alpha cube upon factorial 3, alpha 5 upon factorial 5, alpha 7 upon factorial 7, and so on. Now I will divide all the terms by alpha. It is a 1 minus alpha square upon factorial 3, alpha 4 upon factorial 5, alpha 6 upon factorial 7. So R will be equal to A when the condition that when alpha is equal to 0. When alpha is equal to 0. And I know what is the alpha? Alpha is equal to n delta by 2. And what is the n delta by 2? It is a pi by lambda E sine theta. So if alpha is equal to 0, it means pi by lambda E sine theta is equal to 0. But in this expression, pi cannot be 0, lambda cannot be 0, E cannot be 0. So only sine theta will be 0. It means sine theta is equal to 0. It means theta is equal to 0 degree. So for the theta is equal to 0 degree, we will get, whenever the theta is equal to 0 degree, we will get the principal maxima. In the previous slide, we can understand this, that theta is equal to 0 degree means when the ray will travel parallel to the so after diffraction, when it travel parallel, then it will go, then the theta will be 0, and at this point we will get the central maxima, principal maxima. Now second case is for the minima. Again, we will start with our main expression. Our main expression is R is equal to A sine alpha upon alpha. And for the minima, for minima, we know that the for minima the intensity will be 0, and intensity will be 0, it means the amplitude will be 0. It means for minima r should be 0. If r is equal to 0, it means either a 0 or either a is equal to 0, either a is equal to 0 or sine alpha is equal to 0. A cannot be 0 because this is the sum of all the small secondary sources. Only it is possible that the sine alpha is equal to 0. If sine alpha is equal to 0, means alpha should be 0, pi, 2 pi, 3 pi, but and so on. But we cannot take alpha 0 condition, because alpha is equal to 0 condition give principal maxima. We already proved that principal maxima, that alpha is equal to 0 give the principal maxima. It cannot be suitable for the minimum condition. So alpha, for minima value, alpha should be alpha is equal to plus minus m pi, but m will start from 1 to 3 but not 0. And we know what is the alpha. Alpha is equal to pi by lambda e sine theta is equal to plus minus m pi. We will cancel out pi pi. So what is the part difference? Part difference is the e sine theta, and part difference should be m lambda. This is the condition of the minima. This is the condition, and it is a very, very important equation for the single slit numericals also. E sine theta is equal to plus minus m lambda, where m start from 1, 2, and 3. Now the third and final and important case, this is the secondary maxima. Secondary maxima. As in a mathematics, we know that for a secondary maxima and minima, we will take the differentiation of first order differentiation, then we will put it equal to 0. So what is the r? R is equal to a sine alpha upon alpha, but we are searching for the intensity, so we'll convert into the intensity. We know intensity is the square of amplitude. A sine alpha upon alpha, this is the intensity expression. So differentiate the di over d alpha intensity with respect to alpha. It will be 2 sine alpha upon alpha. Now differentiate sine alpha. Alpha as it is, sine alpha differentiation is cos alpha, then alpha is 1, then sine alpha same, then alpha is square. Now for the secondary maxima, we will put di over d alpha is equal to 0. This is the condition we already know. So if I put it as 0, either this factor is 0 or this factor is 0. Or this factor is 0, but this factor cannot be 0, because if sine alpha is because if this factor is 0, it means sine alpha is 0, but sine alpha is 0 for the minima. So only the condition, the possible condition is that alpha cos alpha minus sine alpha factor is equal to 0 for the secondary maxima. It means alpha is equal to 10 alpha. So there is a condition. We will take the another constant which is equal to y is equal to alpha and y is equal to 10 alpha. So we will draw the graph between the y is equal to alpha and y is equal to 10 alpha. You know y is equal to alpha is the graph of a straight line, and y is equal to 10 alpha. This is the again graph. So y is equal to 10 alpha. And this is the graph for alpha versus y. So this is y is equal to 10 alpha, and these graphs belong to the 10 alpha. This is 0. This is pi by 2. At the pi by 2, 10 alpha, 10 pi by 2 goes to infinity. So this graph goes to infinity. Now I will draw the 10 graph for the pi by 2 and 3 pi by 2. At the 3 pi by 2, this graph is goes to infinity, but in between this pi by 2 and 3 pi by 2, there is a pi, and at the pi, the 10 pi will be 0. And this is the y is equal to, similarly, this is the 5 pi by 2, and so on. And these are the 2 points at which the y is equal to alpha intersect the graph y is equal to 10 alpha. These are the some points. So these are nearly equal to alpha is equal to, but alpha is equal to pi, at alpha is equal to pi by 2, these two graphs will not intersect to each other. But at alpha is equal to 3 pi by 2, at alpha is equal to 5 pi by 2, and so on. At these points, these two graphs will intersect to each other. So I can write commonly that alpha is equal to 2m plus 1 pi by 2 is the point of intersection where m start from 1, 2 and 3. So I can find the intensity curve for this. For this, the intensity curve is, I know I is equal to a sine alpha upon alpha whole square. So for the central maxima intensity, this is the intensity for the central maxima, and this is the intensity for the first secondary maxima, and this is the intensity of the minima. This is the intensity of the second secondary maxima. So for the intensity of the first maxima, first secondary maxima, I will put alpha as a 3 pi by 2, as 3 pi by 2. And I will calculate the intensity of the secondary maxima. The intensity of the secondary maxima will be 4a square upon 9 pi square. And it is around 4.5% of principal maxima intensity. It is a 4.5% of the principal maxima intensity. So the reference books for this by the Brijlal and Subramanya, and the optics by the Ajoy Ghatak. Thank you so much.